Hi, everyone. Thank you for joining the ASCE Orange County Transportation Development Institute virtual event. It's been a long time, but I see a lot of familiar faces. I'm Mahesh Thuraraja, the chair for T&DI. Our chapter was originally established in September 2016, so that puts us to five plus years right now. This is a team effort, and I want to take my time to introduce our team. So Eric Pfeiffer, who is the vice chair, he's an associate at Bixby Associates. Then Charlotte Wu, she's secretary, transportation engineer at AECOM. Then Stephen Anderson, who's a treasurer, PA project manager at David Evans and Associates. Juliet Su, at-large board member, director of TCA. Ali Zalgert, YMF liaison, payment engineer at GMO Geotechnical. Before we go into the event, I want to thank our event sponsors. So today's event is sponsored by Bix Cardosa Associates and Earth Mechanics. Thank you both. We have an excellent speaker today with an excellent content. We are glad to have you, Dwayne, here to talk about the Gerald Desmond Bridge Replacement Project from concept to completion and what is next for the Port of Long Beach. Thank you all for joining our event, and I will pass it on to Eric to introduce our event and the speaker.
Great. So I'm sure most of you know the Gerald Desmond Bridge Replacement Project, also known as the Long Beach International Gateway Bridge. And it really was an iconic infrastructure project which improved and will shape our trade infrastructure and mobility for the next century and beyond. The bridge accommodates 15% of the nation's imported waterborne cargo, so it's a critical access route for shipping and then also for commuters between the Port of Long Beach, downtown Long Beach, and the surrounding communities. Dwayne, our speaker today, who generously agreed to speak and share his thoughts on the project, is the capital programs exec for the Port of Long Beach. He joined the port in 2014 in this newly created position to oversee all elements of the port's decade-long $4 billion capital improvement program. So some major projects in this program include this project that we'll talk about today, the $1.5 billion replacement of the Gerald Desmond Bridge, with the state's first vehicular cable-stayed bridge. And then also the $1.5 billion Middle Harbor Container Terminal, the most automated and greenest marine terminal in North America. So Dwayne, as Alash mentioned, we'll be speaking about the project from concept to completion, talking about project development, site constraints and challenges, and the innovative technical features employed for the project. And he'll also discuss what's next for the port now that this project is done. So we're excited to welcome Dwayne and appreciate his willingness to speak at this T&DI event. And I'll turn it over to him now for his presentation, and then we'll open the floor up to you for your questions afterwards. All right, Dwayne, if you could share your screen, all yours.
Thank you. Let's see. Let's see here. Can you guys all see that now?
Yes.
Okay, great. Well, thank you for the opportunity to talk about the Port of Long Beach and our commitment to develop and maintain state-of-the-art sustainable marine terminals and the supporting infrastructure necessary to accommodate the maritime cargo needs of the U.S. I'm also excited, obviously, to talk about a project that's very near and dear to my heart, the replacement of the Gerald Desmond Bridge, and I've got some great photos of that, and I'll talk about some of the features. We were able to open that up to traffic last October, in fact, about a year and a week ago, on October 5th of 2020. Just in time for the cargo surge that we're all seeing on the news every day, and ships parked offshore. I'll talk a little bit more about that at the end of the presentation. So, as many of you know, the Port of Long Beach is the second busiest container port in the United States. And it sits right next door to the busiest. Our friends across the bay, that we have a relationship with. We call it a co-opetition relationship. We compete fiercely for cargo. We also cooperate on major projects. I had the privilege earlier in my career of heading up the Alameda corridor construction design and construction program in my former life, and that was an example of the ports working together to address the needs here at San Pedro Bay. But just the Port of Long Beach, over $200 billion a year in cargo value crosses those docks every year, both import and export cargo. It's an essential gateway. We are also identified by the Department of Defense as a critical gateway, and work with the Department of Defense should they ever need to expedite mobilization for any international emergency of any kind. Taken together, the two ports as San Pedro Bay are the 9th largest port complex in the world, given that 6 out of the top 10 are all located in China. It just shows you how large this complex is and how essential it is to the U.S. economy. Roughly 8% of the jobs in Long Beach, for instance, are associated with port operations here. And all told, in Southern California, I think it's like 350,000 jobs here, and over 2 million jobs nationwide rely on trade through this port complex. And in all, about 40% of all containerized cargo transits through the combined port complex here in San Pedro Bay. So the Port of Long Beach is a landlord port, meaning that we develop and lease land and terminals to private operating companies. The port's mission is to invest in projects to enhance marine terminal productivity and to deliver greater efficiency to our customers and improve the sustainability of our operations. The lion's share of our future investments going towards on-dock rail projects. As was mentioned earlier, we're just completing a 10-year, $4 billion capital program with the completion of the bridge and our Long Beach Container Terminal Middle Harbor project. But we continue to have capital projects ongoing. We currently have on the books more than $2 billion worth of future projects over and above the $4 billion that we're completing. About over $1 billion of that will be rail facilities to accommodate increased rail volumes. The port is not taxpayer supported. All of our revenues come from the leases that we enter into with our tenants, and we share in their prosperity. All of the leases are set up where we're a partner with the operating company, and so the better that they do business-wise, the better we do as well. But we do operate as part of the State Tidelands Trust, and so we invest 100% of everything we earn back into the operation and continued investment in maritime facilities and support facilities for the maritime industry. So first, back to the bridge. Mario has talked about a new bridge for a new era. He likes to call the bridge our executive director, Mario Cordero, likes to call it the bridge to everywhere. As I mentioned, last October 5th, 2020, we opened the bridge to traffic. After almost 8 years of construction, traffic operations have been smooth and free-flowing. This new bridge is another major milestone in our commitment to ensure that the port has the most advanced and most competitive facilities in the world. It's one of the largest and most significant bridge projects that have been undertaken in the last decade. And it's a partner. It was developed as a partnership between the Port of Long Beach, Caltrans, Federal Highway Administration, and LA Metro. It's the first cable-stayed vehicular bridge in California. It's got the highest deck of any cable-stayed bridge in North America over the water. And the new bridge costs about $1.467 billion, including the demolition of the old bridge. And it's designed to improve both roadway operations and as well as waterway operations. Ships were limited. As ships have gotten bigger, one of the trends in the industry over the last 20 years has been an almost explosive growth in the size of vessels that carry cargo. In the year 2000, a very large vessel might have been 6,000 to 7,000 20-foot equivalent unit containers. Most of the containers you see, in fact, the one you see here on the picture of the Maersk container, that's a 40-foot or 2 TEUs. Today, we've had vessel calls as high as 19,000 TEUs, very, very large vessels that take longer at berth. And this is also a gateway port, and what that means is that unlike some of the East Coast ports where a vessel comes in and maybe drops off 1,000 containers and picks up 800 and then goes on to the next port. Now, usually somewhere between 80 and 100% of the cargo on a vessel will be unloaded here and then reloaded with exports or a combination of exports and empties, returning back to Asia. We have a lot of direct call vessels that literally come from Asia, call here, and head right back to Asia. But anyone who remembers driving on the old bridge now can certainly appreciate the free flow of the traffic, safety shoulders on both sides, and what every traffic engineer would tell you is a bad idea, and that was a drop lane right at the crest of the bridge. So I don't miss driving on the old bridge whatsoever. The port went through almost a decade of planning for the project. It involved a lot of back and forth, obviously, with the negotiations with Caltrans, a lot of technical work, environmental permitting. There's always a challenge here in California, and particularly in the port environment. And ultimately, with a lot of community input and focus, it was determined that the community wanted to develop an iconic signature bridge here in the port complex. Ultimately, when the bridge is complete, we're in the process right now of transferring the ownership of the bridge to Caltrans, and it becomes part of the Interstate 710 extension on to State Route 7, or State Route 47. The old bridge was basically a city street owned by the port, Ocean Boulevard, and so we'll hopefully get that transferred here in the coming months. The project had to be constructed in the heart of this busiest port complex in North America. And one of the first activities was to demolish some of the connector ramps to the old bridge to make room to begin construction of the new bridge. And so traffic had to be detoured onto temporary roadways to get on to the old bridge. And one of the really important things that had to be done and challenges on this project was to construct and shoehorn this bridge into this very busy port complex while we maintain both rail and highway traffic. And in what ultimately turned out to be record volume years for the port complex. In 2017, 2018, 2019 were record years for us. And of course, after a slow start in 2020, after the outbreak of the COVID pandemic, volumes came back with a roar, and we're certainly in record volumes now. So we were able to keep the old bridge open all the way through construction with some very good traffic management planning and some detours that functioned actually quite well, including features like a triple left turn with all 3 lanes being truck turns. And a lot of trepidation when that was proposed, and a lot of studying went into it, but it worked effectively. And I watched on numerous occasions, watching 3 full loaded trucks making the simultaneous left turn, the triple left turn. So one of the other challenges for the project is that Port of Long Beach also happens to be the center of the Wilmington Oil Field. The Wilmington Oil Field is still in production. It was developed in the late 30s and 40s and 50s. It's the 3rd most productive oil field in the history of the United States. And obviously a lot of oil wells that were installed back in the late 30s and 40s and 50s that have been since abandoned, had to be re-abandoned to current standards in order to make room for construction. So one of the early challenges was to identify and properly abandon to a depth of at least 250 feet to make sure they were below any of our foundations, some of the old abandoned oil wells. In some cases that required new technology to accomplish that. In more than one case, they had to actually send divers down. We had to have a decompression chamber on site for the divers to because of the depths that they were operating in. The entire port is obviously got a high groundwater table. We're very close to the ocean, as you would expect, and that challenged both construction and issues like abandonment as well. The focus then moved to installing the foundations for the bridge. Typically here in California, Southern California, in the port area, we see a lot of cast and drill hole pile foundations. And so, and that was what was elected to be used here. Large, mostly 8-foot diameter CIDH piles with depths ranging from about 150 feet to, I think the deepest was about 190 feet. All of them, each one inspected individually with gamma testing to make sure that the installation was done properly. This is one of the real success stories. There were a total of 352 piles required for the foundations. And installing CIDH piles in high groundwater conditions is always a little tricky. On many projects, you have an anomaly rate, sometimes approaching 10% of the piles installed. Out of the 352 piles installed on this job, we had 2 downhole anomalies. It was a remarkable accomplishment, and credit goes out to Shimmick Construction, who led that effort, and they did they did a fantastic job. So connected to those 352 piles were about 100 columns or bridge columns, and obviously there were 12 piles under each of the two towers. You see in the, kind of in the background there, those bubbles or crow's nests you see at the top of that. That was screening to protect the construction as they were doing the next lift. And as it raised up lift by lift to the total 515 foot height. In some cases, massive pile caps. The pile caps alone for the two towers were about 3,500 cubic yards each. Took about a continuous pour in the range of 12 to 18 hours to complete the pours of those. And obviously, they required cooling systems and things like that to maintain the quality of the concrete and the temperatures. The low approaches tended to be built by conventional false work. Here you can see some examples of that. Most of you are familiar with conventional false work of wood and iron temporary structures that hold in place the formwork to place concrete and allow it to cure roadways. But conventional false work is typically limited in height to an 80 to 100 foot range. Above that, the challenges of constructing temporary false work, and particularly on a repetitive high project like this, these high approaches where you would be assembling it, taking it down, reassembling it, the chance of having something go wrong would be quite high. So one of the innovations that the joint construction design build joint venture came up with was to use a mobile scaffolding system to, in essence, serve as the false work for the bridge segments. The bridge segments are basically conventional cast in place, standard Caltrans cast in place bridge segments. But what was unusual was the use of these large movable scaffolding systems. They've been used elsewhere in the U.S., internationally, but this was the first in California as well. And they were actually designed in Finland, checked in Spain, and fabricated in both Turkey and China, and quite elaborate. And one of the interesting challenges we had to deal with is this considered a piece of operating equipment, which in case it would fall under one regulatory regime from Cal-OSHA, that would require us to load it up to 125%. Nobody thought that was a very good idea. Or is it false work, which requires the double stamp issue, which we tried. So we kind of had to work that out, and ultimately decided that was we treated as false work. Each of these mobile scaffolding systems weighed about 3.1 million pounds of steel, and when the concrete and reinforcement was added to that, it was well over 6 million pounds. So obviously the columns needed to be designed to accommodate that loading for construction, and to be able to tie in this mobile scaffolding system so that it could launch. So, above 100 feet, these mobile scaffolding systems helped them, the crews build a higher, straighter segments of the approaches, and without the need to constantly assemble and then disassemble and reassemble and move the false work. In all, the SFI needed to do more than 50 of these moves. This shows inside the mobile scaffolding system prior to one of the floors. You can see the soffit and stem walls, steel tied in, getting ready for the next floor. The stems and soffits where the concrete was placed first, and then the deck forms installed and the deck floors completed. Once the SFI kind of got going with this process, it generally took about 5 weeks per cycle, counting concrete curing time. Took about a day to advance the MSS and another 2 days to lock it into place, and then the process would start on the next segment. But the resulting product was very much a typical Caltrans cast in place bridge, and wall forms. The towers were completed in lifts. We topped off the towers in December of 2017. And the towers support the cables, and the cables support the main span deck. And as mentioned before, this is the first vehicular cable-stayed bridge in California. The other bridges, cable-type bridges that you see in California, are all variations of a suspension bridge. So once the towers were done, they could begin by lifting what we call the pier table, or the first segment, into place on the cable. The entire deck is actually carried by the cables. There is no vertical structural connection of the deck to the towers other than through the cables. So it's quite an analysis exercise to address the, what tension do you have to put in the cable to get the geometry that you want and account for temperature and things like that. They had to survey the bridge typically at about 2 o'clock in the morning to make sure that they didn't have any differential thermal loading that would have changed the geometry before it's locked into place. So the 2,000-foot main span consists of 1,000 foot between the two towers and 500-foot back spans. And I mentioned the first part was this first section of the deck with 4 cables attached, which we call the pier tables. They then installed gantry cranes. You can see these two gantry cranes on the inside ends of the construction. So there were 2 of those on each segment, and the construction had to occur outward in a very balanced way. Every component of construction materials of the bridge itself needed to be weighed and its position on the deck accurately known, so that you could make sure that you remain in a balanced condition, because otherwise you put a bending stress on the towers and could create an overload condition. So one of the things in doing a cable-stayed bridge is that there's a very comprehensive erection manual that literally identifies and quantifies each step all the way through, and does this time sequence analysis of the stresses to make sure that you both remain balanced and that you're keeping the geometry. So it's actually going to meet in the middle. I mean, nobody's going to want a bridge that does this or that or that. It's got to meet. It's got to meet at the backspans too. So the engineering effort that went into that by the designers and the surveying that needed to be done to keep that on track were actually very impressive. particularly to someone like me that actually went to college in Sliderville. So, obviously the bridge, the old bridge was nearing the end of its useful life. It was what engineers like to call functionally obsolete. It still was working. It wasn't in any real danger of falling down. But it certainly wasn't meeting current needs and did need to be replaced. At the same time, the port was challenged to increase the air draft, and so that's why you see now, once we get the old bridge out of the way, we'll have increased the air draft or vertical clearance over the water from 155 feet to 205 feet. That will accommodate all of the vessels that we anticipate will want to go into our inner harbor area. It will not accommodate the largest vessels in service today. It would not have been economical to try to do that, partly because the terminals that we have in our inner harbor are just not large enough to demand, having a 19,000 or 24,000 TEU vessel. The old bridge would accommodate vessels. Container ships don't come in the same configuration, so some ships as small as 5,000 to 6,000 TEUs had trouble getting under the old bridge, and some as large as 9,000 could get under the old bridge, particularly if tide conditions were right. But kind of the workhorse size, 11,000, 12,000 TEU vessels, 13,000 TEU vessels that we believe will be the workhorse. The 737, the Pacific trade lanes, will be able to access once we get the new bridge demolished. So, and obviously the roadway provided safety shoulders, full width lanes, not dropping lanes at the crest, so just operationally much more safe. And emergency responders. We've had an incident already, had a truck fire. The incident response was much more rapid and easily addressed when you have the safety shoulders and things for the vehicles. Emergency responders to get to the incident site. The cable stayed design, there's 80 total cables holding up the 2,000-foot main span roadway. The cables are actually bundles of cables, 7-strand, 170 KSI steel individual cables. Each of the bundles, depending on its location, somewhere between about 40 and 130 individual cables within that cable bundle. And the longest one is about 573 feet out to the outer stretch. But this, it results in just an iconic, beautiful bridge, long-lasting project designed to last 100 years. It's extremely flexible in seismic events. I'll talk a little bit more about that. The city wanted an iconic bridge, and that's what they got. At night, it lights up with programmable control LED floodlights that illuminate both the cables and the towers, and those can be varied. We don't do the dancing lights like the Bay Bridge, but they do kind of go from one color to another, and hopefully if the Dodgers continue, if they do start winning and make it all the way through, we'll light up the bridge in Dodger blue. As all of you know, Southern California is earthquake country. Small and moderate quakes occur every year, and larger ones are predicted during the 100-year lifespan of the bridge. This bridge incorporates some of the latest seismic design technology. This photo illustrates some of the seismic dampers fitted to towers on the main span. You can think of these as just ordinary shock absorbers like you'd have on a pickup truck or a car, only they're 30 feet long and 3 feet in diameter. And they are designed, of course, to attenuate energy in the event of a significant earthquake. They actually have shear keys in that prevent their movement except in a major earthquake, because part of the problem that they've experienced on other projects is that they continually work and then the seals start to leak and the hydraulic fluid leaks out, and then they might not work when you want if you didn't catch that in maintenance. So these are the bridge is designed a lot like high-rise construction. Tends to be flexible, places of isolation, and that enable the various segments to move. One of the things to accommodate was the main span moves differently than the approach structures. And so the very exotic bridge joints at the two end ends to the main span accommodated a great deal of movement, about 6 feet of movement in almost any direction. So that's is obviously a very important feature. The bridge also incorporates a number of features designed to protect the bridge in this day and age against either accidents or potential terrorism. So one of the features that the city is quite proud of was added to the project was a bike and pedestrian way. It's a fully class 1 separated bike and pedestrian path. It's officially named the Mark Bixby Memorial Pedestrian Path, and the route offers spectacular views of San Pedro Bay and the Port of Long Beach and much of the city's coastline. Although the bridge is open, we won't open the path, the bike path, unfortunately, until we've completed the demolition project. We don't want to have people up there when they're kind of swinging steel and things to demolish the bridge given its proximity. There are some, actually some little, what we call belvederes, or almost like a wayside up at the top of the bikeway. So once we do get it opened, I'm sure it'll be quite an attraction. There's some plaques up there at the top of the bridge that kind of explain the history of the Port of Long Beach and the bridge, and the bridge or the bikeway is officially named by the legislature the Bixby Memorial Bicycle Pedestrian Path. It was named after Mark Bixby, who unfortunately passed away in an airplane crash back in 2011. He was the driving force behind convincing the city and Caltrans to add the bikeway to the project. We're also we have another project under construction called the Ocean Boulevard Connector Project, a bikeway project that's under construction right now that will provide a very safe access to the downtown Long Beach bicycle network. You can connect up to the Bixby bikeway. This project is anticipated to be completed in September of next year. And together with the bikeway that we have that goes out Pier J, we have quite a bit of bikeway here within this industrial port for the public to access and enjoy the views and get some exercise. So now I move on to another one of our major projects, Long Beach Container Terminal, or what we often call Middle Harbor. It's a $1.5 billion state-of-the-art marine terminal, container terminal with virtually state-of-the-art technology, automated guided vehicles. You can see these little green things. Those are completely automated. There is an operator in the ship-to-shore crane who operates the crane while a container is over the vessel for safety reasons. once that is clear of the ship, it may have picked up 240s or 420s at the same time. Those are brought back by the crane and then set onto a platform back here, and then by automation. From there, they are then lowered onto these AGVs and moved over to the container yard. Everything in back of from the back of the wharf is all automated until you get to the outgate area of the terminal. One of the reasons that this terminal is so efficient is that these container cranes in the yard are constantly optimizing the placement of these containers because to make it more efficient and to make the truck pickup or the movement over to the rail facilities as efficient as possible. If you didn't have that artificial intelligence optimizing system, it would never fail that the container you want's at the bottom of the stack and you got to go move 10 containers to get to it. And then you got to move those back and repeat and do that. One of the keys to efficiency of a marine terminal is to try to lift the containers the minimum number of times you can to get it out the gate or get it out to the rail to go out the terminal. The first phase of this project opened up in 2016, and we finished up phase 3 last June, and that phase is now in the early stages of operations. And this terminal has an annual capacity in excess of 3.4 million TEUs, which when you compare that to other ports around the U.S., that terminal by itself would be about the 5th largest terminal, slightly larger than Seattle-Tacoma or Northwest Seaport Alliance. They're known today, combined just in this one terminal. It's obviously very efficient as part of our commitment to environmental stewardship. In addition to the 1.5 million that we invested, LBCT invested about 700 million in operating equipment. They own these AGVs, automated guided vehicles. They own the container yard cranes, the rail yard cranes, and the rest of the operating equipment, as well as the computer systems and that actually operate the terminal. So the port built the basic infrastructure, the wharf, the backlands, the container yard infrastructure, the rail yard, and the buildings, the support buildings that are necessary on the marine terminal. And they bought the operating equipment that operates the terminal. We had entered into what was the first for the port, a 40-year lease to, at that time, OCL. It's since been sold to an investment firm that includes Macquarie Capital. So one of the things about the terminal is that the AGVs, all of the cranes are all zero emissions, they're all battery. The battery packs weigh several tons. The equipment knows when it needs to go back. It goes back to a battery exchange facility where robots basically take the old batteries out and put the new batteries in and it's dispatched back into service. All handled automatically without people needing to be in that area. In fact, if somebody does go into that area, it shuts the whole system down. So to support our on-dock rail facilities and looking forward, in the future, the port's going to continue to invest in near-dock rail facilities to smooth and enhance rail access and train arrival, makeup and departure operations, so that we can take advantage of prior investments that we've made in on-dock marine facilities. One of the big projects is our Pier B rail yard support facility, and we hope to begin phase 1 of that in 2023. Here's kind of a depiction of the area where that our existing Pier B rail, you can kind of see where the rail cars are now, but when it's completed, it will fill this entire area with rail tracks. And that'll allow us to optimize rail traffic. Actually, it enhances rail operations throughout the port complex. Even Port of Los Angeles will benefit from this. But we have a bunch of early rail projects. A fourth track at Gasper Control Point. We'll create a 10,000-foot track. We're expanding our west expansion facilities to lengthen some tracks and do a number of other projects over the next several years. We're also going to do a double track access project on Pier G, Pier J, the fourth track at Ocean Boulevard, and the Terminal Island Y project, which you can see kind of where this is at here in this area, will allow for increased rail fluidity in and out of off of Terminal Island, as well as access to other port facilities. We received a $14.5 million grant to support that particular project. We also invest in other port facilities. We're basically responsible for, in the Harbor District, all of the public infrastructure, including things like fire stations and that would support our activities. This is a picture of a new fire station that we built that houses both the regular fire trucks, and as well in the background there's a over the water building that houses one of our new state-of-the-art fire boats. And this project was just recently completed and dedicated, and the fire department has moved into it. And obviously all the construction we do is designed from an environmental stewardship leads status to as sustainable as we can. This shows more of the water side area where the fire boat work. Both of these our two new fire boats represent significant upgrades for the port for business continuity and security, and we have two of these. They are probably the best, most well-equipped fire boats anywhere in the world right now. And the ships got taller. Old fire boats just did not have the ability to respond effectively to fires that you might get on a 18,000, 20,000, 22,000 container ship. So along with investment in those kinds of basic infrastructure facilities, the port also prides itself on being the green port. Felt in still where the green port thing. In 2005, the Board of Harbor Commissioners adopted what we call the Green Port Policy to guide decision making and as a framework to achieve sustainable, environmentally friendly port operations. We've committed to addressing that. We're known throughout the industry as a leader. We do a lot of this in joint cooperation with the Port of Los Angeles, because obviously you kind of need to do things together in this gateway. But our goal is to promote sustainability, employ the best technologies, and engage with the community. So one of the benefits is that we've seen a vast resurgence in our marine habitat diversity. We do an annual survey. We just released in April. there, the surveys show that there's now more than 60% more biodiversity in our harbor than there was just a decade ago. I've been down there, where I could literally see into the water as much as 10 feet. And I would dare say that there's no major industrial port complex anywhere in the world where you can say that. Fish and kelp are abundant, and you often see sea lions and dolphins in the harbor. And they're seeing species that probably haven't been seen in these waters this close to operations since before World War II. So in 2017, we updated our Clean Air Action Plan jointly with the Port of Los Angeles, and set a zero emission target of 2030 for terminal equipment and 2035 for all the drayage equipment that operates into and out of the port. Our Clean Air Action Plan, to date, from its adoption back in around 2008 timeframe, has been pretty successful. We've seen an 88% reduction in diesel particulates, 98% reduction in sulfur oxides, and almost 20% reduction in greenhouse gas. All that occurred while we've had more than a 14% increase in TEUs, and that's we've got more to go. So we worked with our partners to secure about 80 million in mostly state and some federal grants to demonstrate zero emissions equipment. And the grants are helping to pay for about $160 million worth of projects across the port, reaching into all 6 of our container terminals. Zero and near zero emissions in cargo handling trucks, charging stations, a microgrid project. We're also installing solar panels and energy storage system in our security and command systems, and this is also part of the electric vehicle blueprint, which we've undertaken with a $200,000 grant from the California Energy Commission to look at electric infrastructure requirements, financing, and other needs. We already have achieved about 15% of all cargo handling equipment in the port complexes is zero emissions. So that kind of concludes most of my comments, but I would like to just conclude with some observations on the current port congestion that you're seeing both here in Southern California and throughout the world. We're just one part of a global supply chain, and interruption of any part of it disrupts the entire chain and affects other parts. The root cause of the congestion that you see is actually changes in buying patterns and the global impacts of the COVID pandemic. As various locations have had to implement COVID protection measures, ports in China, for instance, shut down for weeks at a time, and that causes backlogs that then become surges that translate into this congestion that we're experiencing today. That's caused this surge in demand. At the same time, we've seen a shortage of critical labor and equipment, warehouse space, warehouse staffing, truck drivers, chassis, rail cars, all the components that make up this very unintegrated supply chain network that is typical today. Unlike FedEx, it's vertically integrated from the source to the end customer. The supply chain industry is broken up into segments of it, with multiple parties, and that's one of the challenges in trying to address that. You can if you get one person to do something, that could make somebody else save some money, but it would cost them more. So trying to get past that, the port tries to be in the role of a facilitator of how do we kind of stimulate that process so that we can get those kinds of willingness to do something to improve the entire supply chain. But as and obviously as terminals get more and more congested, it's a lot like traffic. You start to, their efficiency goes down, and that compounds the problem. The larger vessels take longer at berth to load and unload. And that's caused what we're seeing is offshoring and anchoring of as many as 60-some container ships at one time. Historically, we only saw container ships anchoring when we were having labor disruption. Labor disruption at the port has nothing to do with what's going on there. They're doing a yeoman's job of responding to the demand, and it's other elements of the process that are kind of in the way. We are starting to see some improvements. We've instituted some things here at the port, peel-off yards on Pier S, things like that, and but we still have a long ways to go. But on a positive note, what's really driving this is robust demand, and that's I think sends a positive message about where we're at in the underlying economy. So with that, if there are times remaining, happy to answer any questions, and thank you for your time today.
Great, thanks a ton, Dwayne. Certainly a busy time for the port, but we appreciate you taking the time to present to us on all the great capital improvement projects you've got going on, and especially with the Gerald Desmond, the scale of that's just incredible. 500-foot long cable, as you mentioned, recompression chambers for divers, the movable scaffolding system. So just a pretty incredible project. What we'd like to do for questions here is, let me first just go back. So I'd ask that anybody who has a question, enter your name in the chat box, and I just posted a message in there that you should be able to see. So if you just make a note here, I'll try to go through and ask you to unmute and ask Dwayne your question, and we'll get to as many as we can. But while folks are inputting some text in the chat box, if they have some questions here, usually for our T&DI events, we like to take some photos of the folks who attend, and obviously we're unable to do that in a virtual environment. So I might just ask if anybody who wants to be part of our screenshot here can turn on your video, and we'll take a quick screenshot of all the participants. That would be fantastic. So everybody smile.
Yeah, just give maybe 10 seconds, 15 seconds for everybody to turn it on.
Let us know when you got it all, Hash.
Okay. Yeah. Okay, I'll go ahead. Okay, everybody smile. Okay, hold on one more. Okay, keep smiling. Okay, thank you all.
Great. So we got a couple questions in, starting with Adrian Anderson from IDS Group. Adrian, if you could go ahead and unmute and ask your question.
Yeah, hi, Dwayne. Thanks so much for that informative presentation. That was really fantastic. Wanted to ask, we saw a lot of what's happening sort of above the water line and above grade. Was the channel needing dredging at all to accommodate those larger vessels that would be coming through that particular channel? And then also, how's that demolition of the bridge going to occur, I guess, to safely protect the sea life and such below it?
Well, we did not have to do dredging specifically for this. We're blessed with naturally deep channel. The downside of the oil production was that we had a lot of subsidence from pumping all that oil out of the ground over the years, but that's caused us to have kind of naturally deep waterways here. We do have to do dredging from time to time. But the other advantage we have is that the Los Angeles River was diverted to the other side, and it goes out by the Queen Mary and that. And so, unlike a lot of other riverine ports that are kind of at the mouth of the river, we don't have this constant recharge of sediments that have to be dredged. So, while we pay together with Los Angeles the lion's share of the harbor development harbor tax, we're unfortunately not the major recipients of the fund. So we, in essence, we subsidize our competitors on the East Coast and riverine ports.
And if I may, just a quick follow-up. You'd mentioned that the bikeway, the Bixby bikeway, is not yet opened until that demo is completed. Do you have a timeline on that so I can know when to take the family out for an enjoyable ride?
Right now, I believe that we will have the critical part of the demolition done by the end of the fourth quarter of next year. We're still waiting to see the contract. We just gave them an NCP actually yesterday. And the first thing they have to do is submit their formal plan for review. But obviously, the first thing they have to take down is the main span. They actually have to build some bridge first so that they can strengthen it so that they can sever it, the major segment down onto a barge, and then all over to marine terminals to dismantle it. And unfortunately, we have two recycling operations here in the harbor complex. And go out and scrap other than a little bit.
Great, thank you.
Great. Next, we've got Dave Spears.
Hi, everyone. Dave Spears from TCA, and Dwayne, first I wanted to say congratulations and thanks for the chance. I got to meet with you back in January of 20. Fantastic. And I too, this bridge is close to my heart because I think 2002 was when I started working with Kevin Haboyan and a few others on the environmental document. So about 18, 19 years in the making, and what a fantastic result. I thought it would be good for the group if they could hear you talk about, you mentioned it was like tuning a guitar to try and get the bridge, the cables right. And I wanted to ask you, that was one question. The second one was just about how long do you think it'll take before you turn over the asset to Caltrans and they get to own it?
That's always an interesting and obviously very dangerous question in terms of when we get it to there's the deeds have actually already been placed into escrow, and so we have made a lot of progress on that part. One of the things the port agreed to at the beginning of the project was that the port will reimburse Caltrans for the first 3 years of maintenance. And so they entered into an agreement to do that and kind of setting the rule back in 2012. As the project got closer to completion, I think both parties recognized that agreement needed to be modified to both protect the port's interest in continuing to use a lot of the land underneath the bridge. For port and maritime activities, it's too valuable to just let it go fallow, as shade under the bridge. And at the same time, Caltrans had a lot of concerns about how they actually do this. And so we've been working through that process, and anybody who work on TCA, so we know that negotiating anything with Caltrans takes a while. They're a big organization with lots of vested interests, and so we've been working through those issues, little things that you never would have thought of, but have suddenly become concerns, intellectual property rights, lighting, control systems, things like that. And that just takes time. And so hopefully, technically SFI has not submitted the affidavit of final completion yet, but we are expecting that in the next week or two. Then it'll start a negotiation process with Caltrans about whether the kind of outstanding issues that SFI is proposing that would still be worked after designation of final completion is accomplished. And this is a very complex project. So there's a lot of little things that you don't really, it doesn't really warrant delaying final acceptance for some small thing that might take 2 or 3 months to get resolved. And it isn't, you'd probably be criticized later for delaying final acceptance.
Yeah.
So we have to negotiate that out with Caltrans. So, but hopefully before the end of the year, we'll transfer the facility to Caltrans.
Excellent. Well, once again, congratulations, Dwayne.
Thank you.
Great. I think we've got time for one more question here and then we'll wrap it up. So thank you everybody for staying a little long. Jose, if you unmute and ask your question. Looks like you're still on mute, Jose.
Yeah, sorry about that. Thank you again very much for the very enlightening and comprehensive presentation. My question would be, if other types of bridges have been considered for the crossing, I would say other types of cable stay, suspension, balanced cantilever, arches, and also why was it a total complete concrete deck chosen and not an orthotropic steel or a composite steel and concrete?
Well, it is the deck of the main fan is a composite concrete, lightweight concrete panel stitch in compositely with a steel frame. But you mentioned the various bridge types, but typically suspension bridges would be appropriate if the span lengths were longer. If we had to span 2,000 feet instead of spanning 1,000 feet, this is kind of in the sweet spot of cable stayed bridges. Cable stayed bridges are a little more economical per square foot than a suspension bridge. Some of the other types of bridges probably could have been accommodated, but the cable stayed bridge is fairly typical now for spans in this length and maybe a little bit higher. With respect to why this composite lightweight concrete and steel deck, steel orthotropic decks don't tend to be cost effective unless you're kind of getting more to the outer limits of, starting to approach 1,500 to 2,000 foot of clear span for the cable stayed bridge. So I think, partly it's aesthetics, partly it's that's kind of in the middle of the, where the cable stayed bridge is a highly efficient bridge. I think you're on mute.
Did it automatically. One small additional question. It seemed from the clearance that you have shown against the biggest ships that the clearance is still tight. Why couldn't the bridge be higher by some 10 or 20 feet?
Well, it would just mean that every truck that ever crosses it has to go up another 10 or 15 feet. You have to draw the line someplace. And based on the planning and projections available at the time, it made the most sense to try to get 205 feet of air draft. The other thing that the port took into consideration in making that decision was the size of the terminals that we have in the inner harbor. Our big terminals are outside of the bridge and don't, the ones that the 300-acre LBCT are 400-acre Pier T, Pier G, and Pier J out there. Those terminals are outside of the bridge and don't need to, and those are where the biggest ships will go because of the size of the terminal. Pier A, relatively small terminal. Matson, Pier C is the Jones Act, relatively small operation. And so it just didn't make economic sense to build an even bigger project with all of the extra cost, all of the cost of taking trucks up and over and spending that energy to do that. And then extending the limits of the bridge out to accommodate getting up another 10, 15 feet. So it was a very carefully thought out decision on where to draw the line.
I see. Thank you very much. I appreciate all your answers.
Very good. I think with that, we will conclude this presentation. Thank you, everybody, for joining, and a special thanks to Dwayne for all the time and the great presentation and answering the questions. Just one quick note for everybody. Our next event is going to be Tuesday, December 14th, and we'll feature Daryl Johnson from OCTA to give an update on their projects. So we hope you all be able to join that. And thank you again for your time today. And we will be posting a recording on our website and hope to see you at future T&DI events.